Hi everybody, welcome to Seattle, Washington. Bedrock is a rare thing in Seattle. There's mostly glacial deposits, but if you know where to look, you can find some honest-to-God bedrock. And this is Alki Point, and you might be able to see over my shoulder that in amongst the beach rocks, there's some honest-to-God bedrock here. It's the Blakely Formation. Let's talk about what we know and what we don't know about the Blakely Formation, sedimentary layers, bedrock in Seattle, Washington. Thanks for joining us. Let's get started. Well, it couldn't be more perfect on a Friday at about noon here in Seattle. Seagulls, ferry, and this shelf of bedrock. And you're like, my God, I would never know that there's bedrock here. You can't even see the rock, can you? Well, no, you really can't. But the few kernels of information I've been able to find online helps me understand that this is the Blakely Formation. And I've used the hammer just a little bit to get in to the bedrock, which is not easy here in Western Washington. I mean, high tide was here not that long ago, and we have some very fresh, beautiful creatures that I don't want to disturb too much. But what I have done, let me do one more just to give you a feeling for the sound of this. So I grabbed a clear piece of this bedrock. Ready? Hi-ya! More work than I wanted. Oh yeah, that's good. That's good. So, relatively hard bedrock. And if I zoom in, maybe you get the sense that this is a sandstone, a sedimentary unit. How tight can I get in here? Some sparkly little sand grains, surprisingly dense. And I'm not going to be able to show you a whole lot more than that because of these barnacles, and I'm not going to say what else is here because I don't know much biology. But this look of this sedimentary bedrock is here, exposed at low tide at Alki Point. So if I give you a sense of this, maybe you can get a feel for the slight dip, which I think is real, of these sedimentary units. We're looking across the way at the Olympic Peninsula on a gorgeous mid-July day. I presume that's Mount Olympus, but I can't be sure. So across the way, just beyond that ferry, is Restoration Point. Oh, some ferry sounds even from over here. Beautiful. And so Restoration Point factors into our story here today, because Restoration Point over there and Alki Point over here are two little islands of bedrock surrounded by a sea of glacial deposits. And so the bedrock is significant. And as I mentioned in the open, if you're in the Puget Lowland, you just don't get a chance to see this bedrock very much. Why not do it? Let's do it now. The Seattle Fault is right around the corner here. And the Seattle Fault sits east-west. And so this side, or in other words, the south side of the Seattle Fault has been lifting abruptly every time there's been a major earthquake on the Seattle Fault. This is not the Cascadia subduction zone story. This is something more local due to clockwise rotation and the crustal compression of this crust. And through the work of Brian Atwater and others, we've been able to deduce that the most recent earthquake on the Seattle Fault, an east-west structure, is 1,100 years ago. And some Sunday morning, 1,100 years ago, there was 21 feet of sudden lifting of this bedrock south of the Seattle Fault. Same for Restoration Point on the other side. George Vancouver, one of the first explorers in this body of water, noticed this freaky thing called Restoration Point. And so the idea is that this bedrock is exposed at Alki because of the repeated earthquake action on the Seattle Fault. And you're like, tell me more. When was the more recent, what was the subsequent? And you're like, tell me more. If the most recent Seattle Fault lifting of the bedrock was more than 1,100 years ago, how about the earthquake before that, and the earthquake before that, and the earthquake before that? These are repeated earthquakes, aren't they, on this thing called the Seattle Fault? The answer is yes, but we don't have those dates. We don't know the average number of centuries between uplifts, but we do know that there have been multiple earthquakes because of this consistently high position of this bedrock. Put it another way, north of the Seattle Fault, just around the corner, the bedrock is thousands of feet below the surface. This bedrock is thousands of feet below the surface around the corner. That's how significant the Seattle Fault has been and will continue to be. It's still an active fault. So because we're south of the Seattle Fault, then we get a chance to see this stuff as opposed to having to dig thousands of feet below the tidewater of the Seattle Fault north of downtown. So this is the Blakely Formation. Let me flip you around. So some of you were paying attention to what I was doing this past winter. And we were doing the Cascades A to Z, but we weren't really looking at the Cascade volcanoes themselves. We were looking at the long history of the Cascade volcanoes, going back 46 million years. And we worked out all sorts of stratigraphy involving very old bedrock units that are exposed within central and western Washington, many of them pertaining to the long history of the Cascades, some just kind of background noise for the history of the Cascades. So the Blakely Formation is mostly poorly understood. And I don't think it's just me being out to lunch. I think that's truly the case. So let me show you on my iPhone a significant stratigraphic cartoon that we went to repeatedly this past winter. And I think it will put this Blakely Formation into perspective, because you're like, show me more. Well, I'll show you more. You're like, okay, I'm showing you more Blakely Formation. What do you want from me? I can't show you anything. You're like, this isn't good enough. I need to see the layers of this Blakely Formation in a canyon wall somewhere, or I don't think you're going to find it. That's why this Alki spot is so significant. That's a good looking, natural look at a sandstone here. These little guys waiting for the next high tide. All right, well, let's find a spot where I can set down this phone and show you this little cartoon. Okay, here's our computer screen. Here's our pointer. Ready? Begin. 60 million years ago to 30 million years ago. These are many different layers that we've been studying this past winter with the Cascades A to Z. Crescent formation, that's Silesia. Remember, we had a color scheme. Blue was the decade of the 40s. Green was the decade of the 30s. And most significantly, in green time, was the Ohanapikosh. You remember? During the Ohanapikosh time, between 35 and 30 million years ago, there were no Cascades. There was no major elevation in Washington. And those submarine volcaniclastic deposits were telling us that there was plenty of volcanic activity in what is now the Cascades, but it was underwater? Well, I think generally we understand that the Blakely Formation, notice it's in quotation marks, that's interesting. The Blakely Formation is also green. In other words, green time. Like when we have submarine volcanism to the east of here, I guess we have this, must be mostly marine sand being deposited in the Blakely. But do we have exact dates out of the Blakely Formation? Do we have any volcanic ashes that we can get ages from? It sounds like there are scattered reports that we do have that, but nobody's really worked on it quite yet. Until now. I'll tell you who the mystery geologist is who's about to tackle some of this in just a second, or maybe you can guess. But sticking with this is the first time I've shown a diagram on my iPhone in the field. I kind of like it. We're going from the Wenatchee Formation over by Wenatchee in central Washington to the Blakely here at Alki Point. We've got Ohanapikosh up in the Cascades today, but again, no elevation then. Lincoln Creek, I guess, is over a little bit south of here at I-5. And there's even a sandstone of Summit Creek at the same time that's exposed today up at White Pass. So it would be fun to find some new research to tie these places together, to somehow get some tephrochronology. Can we find a volcanic ash at each of these locations and is exactly the same volcanic ash? And if so, can we then get a timeline going through all these scattered exposures? And what else can we do with these deposits? I feel like I should give you more about just the outcrop here, and then I'll finish this short video talking into the camera just a bit. Yeah, I'm standing, I'm walking on Blakely Formation, exposed at low tide. And I don't know if it's the most sexy looking bedrock I've ever seen, but the fact that it's here, because we're south, immediately south of the Seattle Fault. In other words, we're on the uplifted block side of the Seattle Fault, and that Seattle Fault seismic activity continues to jack this bedrock up and up and up. And so we keep bringing fresh Blakely Formation to the surface every time we have a big crustal earthquake, shallow crustal earthquake. The last time it happened, 900 AD. If you were out here by yourself without this video, would you get more and more comfortable that this was solid bedrock instead of just a bunch of beach rocks? I think you would, wouldn't you? Like right in here? I'm kind of glad I came down this far. It's kind of lonely out here. Everybody's in the tide pools. There's one creepy guy with a microphone on looking at the bedrock. Stay away from him. So can your eye pick up what is bedrock and what is a bunch of glacial stones that have been rolled around in the tide? Hopefully you can. Can I help you out? My foot is on the Blakely. This tan, solid bedrock is our topic today. These stones are all from Canada that have been brought down in the last 3 million years. So if you wanted a different way, do you? You want it a different way? The tan bedrock is more than 30 million years old. The loose stones were brought in here less than 3 during the Ice Age. But as you well know, the glaciers are bringing Canadian rocks from many different mountains, and so each of these glacial rocks has a different story. I'm not saying that each of these rocks are 3 million years old, right? I'm saying they were brought in less than 3 million years. But it's an interesting place to study a difference between Ice Age rocks, which are a dime a dozen, And you might go, tell me more about these glacial rocks. Well, those are the other videos we've done. And some of them are green, Gary Paul. But we can see, can't we, that there's substantial amounts of Blakely Formation, not just a little bit. And I'm glad I came down this far south. You're looking north, by the way, right now. So as we're walking back north to where I started the video, I hope you're getting comfortable with walking on bedrock that normally is thousands of feet below the surface. That's the magic of Alki Point. Blakely, sitting on top of the Puget Group, so officially not part of the Puget Group, apparently. So who is this geologist who's going to work in this wheelhouse, in the blue, in the light blue and in the green with sedimentary rocks of central and western Washington? I think you know the answer, don't you? Her name is Erin Donaghy. Dr. Erin Donaghy from the geology department at University of Nevada, Las Vegas. Erin is still in her first year of teaching geology in Vegas, but she is coming up with her brand new graduate students this summer, next summer, and beyond to work out in the Olympic Peninsula, to work up in Alaska. But I think at some point on Erin Donaghy's bucket list is the Blakely Formation and many of these other bedrock exposures in the Puget Lowland. And she will do the treatment that's necessary to tease out brand new stories on bedrock units that I think have been mostly overlooked for 50 plus years. No offense to those geologists who might be watching this who were doing some work 30, 40, 50, 60 years ago, but I think there's all sorts of ripe opportunity for new, detailed stratigraphy and tephra work within the Blakely Formation, among many others. Let's flip you around for a couple final shots, but thanks everybody for watching this one.